And what this means is if you take a set of factors and you multiply them out, take a product of factors and multiply them out, they get what's called expanded into polynomial form. And so we're going to go through a couple basic steps that you should follow for these, and then we'll go over more specifically the special forms that you need to be familiar with. Okay, so first, when you're multiplying factors, the first thing that you need to be able to do is apply the distributive property. If you recall, the distributive property looks like this. If you have a monomial, or it could be multiple terms, but and you're multiplying by another multi-term factor, you just distribute, you do what's called distribute that product through. So you take the factor A and you multiply it by both B, and then you add that to the product of A times C. And so this is a process that you guys should have seen, should have been familiar with. An example of the distributive property would look something like this. And if I were to talk through the steps for this, again, this should all be a review for you. But you distribute this monomial factor times this binomial factor. When we distribute that through, we're just going to multiply both terms of our binomial by that monomial factor. So 5x times 3x, you multiply the numbers. 5 times 3 is 15. Then you multiply the x's. X times x, you're multiplying two exponents with the same base, so you add their powers 1 and 1, gives you a total of x squared. And then you take and you distribute your 5x, that monomial factor, times the other binomial term, negative 2. So 5x times a negative 2, negative 10x. Okay, and so that would be the distributive property in action. And now, this isn't just a monomial factor times a binomial factor. It could be two binomial factors, and it could be more than factors with more than just two terms. But if we took this example here of these two binomial factors and we distributed, okay, so if we took this first term x and we distributed that to both of our terms, okay, in doing that you get x times 3x, which is 3x squared. X times a negative 1 gives you negative x. And then you move to the next term of that first binomial and you distribute it. 2 times a 3x gives you a total of plus 6x. Notice I wrote it in a vertical stacked method right below the other like term x. And then you distribute this 2 to the negative 1 is a negative 2. And so when we combine these straight down the columns, we get an overall polynomial of 3x squared plus 5x minus 2. Okay, now, when you multiply two binomials, you guys know this by another name, right? What does this look like to you guys? Foiling, right? When you took the first terms of these binomials and multiplied them, that gives you 3x squared. When you took the outer terms, x and a negative 1, gives you the second term. When you take these 2 and the 3x are the inner terms, that gives you 6x. And when you take 2 and the negative 1, that gives you the last terms of your binomials. Okay, so this is just the FOIL process. Okay, foiling is just another way to name a specific case of distributive property, and that's the case where you're multiplying two binomials. Okay, so again, we'll go through some other examples later on in some of the work that we're doing. Okay, where you'll see that more terms than just two, but you can distribute any number of terms. Okay, so that's one way that you can look to expand polynomials. The other way is to apply one of these special product forms, and these are the three that you need to be familiar with in this section. All right, the first is the sum and difference of terms. When you apply the sum and difference of terms, what that means is if you took the sum of two terms and you multiplied by the difference of those same two terms, so A and B, only the opposite sign between them, that always expands into, if you were foiling here, we would see that we get A squared, the first. Our outers are negative AB, our inners are positive AB. Okay, the outer and inner products for the sum and difference of terms form is always going to be exact opposites of each other. So they cancel out completely. Your last term, negative b squared. And so you get the form a squared minus b squared. So that's what the sum and difference of terms always expands into. It expands into the difference of their squares of those terms. Like I said, I'll go through individual examples of these here in just a moment. Okay, the next special product form that you should be aware of is a binomial square. And binomial square means if you took any binomial and you squared it. And once again, really what you're doing on this is you're foiling a plus b times a plus b. And when you FOIL that, you get your first terms a squared, your outer terms plus ab. Your inner terms are going to be the exact same product, right? Plus ab again, and then your last terms are b squared. And so when you simplify this, you get a squared plus twice the product of the basis of those terms plus b squared. Okay? And so your binomial square expansion pattern looks like this. Okay? It's the first term squared plus twice the product of the terms plus the second term squared. And then the third type of special product form you need to have memorized and be able to apply without a calculator is a binomial cube. And if you expand a binomial cube, and I'll talk about how it's derived as well as what the pattern is, the pattern is simply going to be the first term cubed plus 3 times the first term squared times the second term, plus 3 times the first term times the second term squared, plus the second term cubed. Okay? Like I said, I'll derive this and show you how to apply it here in just a moment as well.